Good morning, good afternoon, good evening, and welcome back. We are now doing part 3 of the application of geometry 1 cosine rule, and the question C says calculate the value of x for which the triangle exists. In other words, we want the range of values of x for which it is feasible to draw this triangle PQR. This is a very interesting question, very challenging, requires you to think out of the box, and let's look at it. See, we have already established that cos theta equals to x squared plus 3 over 4x. And from our knowledge of trigonometric functions, we know that cos theta is a trigonometric function. And as a trigonometric function, cos theta ranges from -1 to 1. It cannot go beyond 1, and it cannot go under -1. So, if we call this our equation 1, using 1, we can say -1 is less than x squared plus 3 over 4x, which is less than 1. So multiply through by 4x, we have minus 4x less than x squared plus 3 less than 4x. Then we can make two inequalities out of these, which are minus 4x less than x squared plus 3 or x squared plus 3 less than 4x. We can call this our equation 2, and we can call this our equation 3. So we can basically drop a line there, and then looking at 3, we have x squared minus 4x plus 3 is less than 0. You just take 4x from the right hand side and put it to the left hand side. Then we can factorize, and in factorizing we know x factors are x and x. The factors of 3 that will give us 4 are 3 and 1. We have a plus sign there and a minus there, so we have a minus and a minus there, meaning that minus x minus 3x gives us minus 4x, but minus 1 times minus 3 gives us a 3, and this is 0. So this expression should always be less than 0 for this inequality to hold, and those values of x that satisfies this inequality will give us the values of x for which triangle PQR is indeed feasible. So if x is equal to 3, this whole thing goes to 0, and this inequality does not hold. And if x is equal to 3, this whole thing goes to 0, and this inequality does not hold. So if we have x less than 1, we will have 1, this is a number that will be smaller than 1. So this will give you a negative, and this number is also smaller than 3, and that will give you a negative, and a negative, and a negative will give you a positive, so this inequality will not hold. So if we have a number that is less than 3, say we have got a minus, if we have a number less than 3, we have a number greater than 3, because we need to remove this smaller number here. The bigger number, if we subtract from 3, it will be positive, and this will be positive. So the two multiplied together will not satisfy the inequality. So if we have the 1 less than x and x less than 3, the inequality will hold. For values of x less than 1, this, let's say we have 2, 2 minus 1 will give us a 1, 2 minus 3 will give us a minus, and this inequality will hold. If we have a 3, 3 minus 1 will give us a 2, and the 3 minus 3 will give us a 0, so slightly lower than 3, this inequality will hold. And so from this analysis, the values of x that are such that 1 is less than x and x less than 3 will ensure that triangle PQR exists. So, before we conclude that this is done, let us consider the left-hand side where we have this inequality. So, this is the solution. But here we want to see if we can get any feasible solutions that will satisfy that requirement. So we can multiply through by minus 1, or we can bring 4x to the other side and have the zero. If we add 4x on both sides, 0 less than x squared plus 4x plus 3. Then we will have the x squared plus 4x plus 3 is greater than 0. And if we factorize, we have x there, 3 and 1, and this will be x, this will be a plus and a plus. So 3 times 3 gives us, 3 times 1 gives us 3, 3 times x is 3x, plus x gives us 4x. So this number should be greater than 0. So if we have x is equal to 0, for instance, this would be 3 times 3, it would be 3, that's greater than 0. And if we have the x minus 1, this would be 2, and this would be 0, so it doesn't hold. If we have the x minus 2, this would be minus 2 plus 3, that would be 1, minus 2, so it won't hold. So any values of x that are greater than the 0 will actually hold, and that is not a feasible solution. This would not work, and our solution is on the right hand side. Thank you.